check the tension on the actual belt before it would, right?
It's excellent. Hello, my name is Chris English, and I'm the president here at Southeastern Community College. And today we've got another episode of Tech Talk, and of course Josh and I are sitting here working on this great mechanical tool that we use in class. And we want to talk to you today a little bit about a new program that we have called Industrial Systems Technology. And as a lot of y'all know, we offer mechatronics engineering, and we also offer electrical engineering. And it's something that we've had at the college for quite some time. And the one that's been kind of the most confusing to understand is mechatronics. Mechatronics is a program that obviously companies in our industry needs, but it focuses a lot on automation. It's a lot of mechanical and electrical and understanding the automation of a program or of an industry or of maybe a piece of equipment that might be operated. We want to go over that a little bit today. And of course, you know Josh Smith, he's our electrical engineering instructor. We have introduced you on this show before in the past, and you've been at the college now for probably a year, maybe a little bit longer. Is that about right?
Yeah, August to be 2.
August to be 2 years. Wow,
Yes,
time flies is that quick.
Yep.
And so obviously, looking at mechatronics, we've had a lot of conversations about that. One of the things that we ask you to do is really look at industry needs and seeing, what they may need and listening to our advisory committee. And one of the things I think that's come up, it's surfaced, is the need in our local business and industry, the Industrial Systems Technology program. Like mechatronics is getting really people to understand that. So tell us a little bit about Industrial Systems Technology. What would a student learn in that program versus automation in mechatronics?
So with industrial systems, students really learn a bunch of disciplines. They learn how to install, service, maintain, and inspect different industrial systems that you might see in a plant. They're really an all-around technician.
Okay, that's fantastic.
Yes, sir.
And so much like what we were doing here, servicing this belt and this mechanical device, the length of operation and the ability for a piece of equipment to maintain its operation really depends on these technicians, right?
Yes, sir.
So what could a student expect in the industry when they go out to do these jobs? What would life look like to a student? Either in the beginning or a seasoned student, that's been in the field 3 or 4 years, they may have a different experience. Kind of, what would that look like for somebody?
Well, with industrial systems, with a technician that would be studying these disciplines, they'd be looking at a bunch of things, hydraulics, electricity, PLCs, pneumatics, various different disciplines will be looked at. But the big thing with this guy, or whoever will be studying this, would be installed. So they would be at the beginning of the system working, installing it, keeping it up, repairing it when it breaks.
Whatever type of mechanical device might be there. Something similar to this, where all the gearing and things, the belts that you see, this is something really that Festo, the people who built this, try to match the industry, right?
Yep, for sure.
Yeah, and so that's critical to understand a lot of that technology.
Right, because we do know, there are mechanical parts in here. There is electricity in here. Most systems do have various different types of technology that's incorporated in it, and having someone that knows a little bit about all of it makes them a better employee.
Right. And this is a 2-year degree program, right? They can get a diploma, I guess, and some various certificates. And obviously, I would assume that for the seasoned technician who's out there in the field 20 years, they may come back and take this in a workforce development short-term class.
Yes, sir.
Could. What about transfer opportunities? What's there?
Transfer opportunities, that's great. East Carolina's got two different paths that you can take. One being industrial engineering, the other being construction management. So you can kind of get into an engineering role where you might put your hands on it, or to a management position where you're a leader. They do accept all of the credits from Southeastern, so fantastic. You go in pretty much with 2 years under your belt and 2 more to finish.
Yeah, that's fantastic. That's fantastic. And so I'm assuming that we've got quite a few companies that are probably involved in this, who use this, as a resource to have a workforce pipeline.
Yes, sir.
Right. Sure. So with new students that are coming in this, let's talk a minute about those companies and their opportunities that they're providing. When a student comes in, obviously they're not going to be a seasoned tech. Right. What about apprenticeship programs connected to this, or internship opportunities? How do you go about getting students engaged in the workforce in a field like this?
I think first and foremost is actually selling the benefit of the program to the student, letting the student know, hey, you'll be the go-to guy for keeping these systems and the money flowing in for these companies. You know, and selling it to the company the same way. You know, this guy's going to be a robust addition to your team to, you know, keep your systems up and running.
Yeah, because if this thing is not operating correctly, if that assembly line is not operating correctly, I mean, that's a huge cost to that company over a period of time. If the machine shuts down, obviously they're not producing product.
Right.
So this student's, or this potential employee as the future rolls out, is really keeping the company going.
Sure.
I mean, they're key.
Right.
That's, to me, significant. That means that person's very, very valuable.
Right.
I mean, everybody's valuable in a company, but if that equipment goes down, you're done.
Right.
Obviously, pay's got to be pretty good on some of this.
It's pretty good for someone starting out. Anywhere from about $45,000 a year to $54,000 a year.
Great. And is that, when you say starting out, is that coming out with a 2-year degree, or is there, you know, I always kind of use the term when I taught automotive, you know, I always felt like automotive technicians had about a 3-year learning curve, because you had to see that car every day to understand this is the problem that's occurring with that car. What is that kind of the same thing for a student sometimes?
Well, that's the range for someone starting out. There's plenty of potential to grow. You know, any manufacturing plant you walk into, they're going to have different manufacturers of equipment. So there's a learning curve that needs to be done.
And different makes. I mean, like this is a Festo. We know Festo is a German company, a European company. They make a lot of equipment for manufacturers, but there could be somebody else. You got to learn that piece of equipment.
Then you go with age of the type of product you're using. You know, companies change throughout the years.
So the person's in this, they graduated from Southeastern Community College, maybe they went to a transfer program and they've left, now they're in the field, they've been out there 5, 10 years, they're a seasoned tech, they're a Josh out there.
Sure.
What do you think that salary looks like for somebody who has that kind of experience?
I would say 70 plus.
That's awesome, that is absolutely fantastic. It's, you know, not a lot of people see that kind of money in their careers. And for somebody who potentially coming out with that, 20 years old, right out of high school, maybe goes to a transfer program, now they're 22, making $70,000, $80,000 a year. That's pretty good money.
It's a life changer.
Even for somebody who's an adult, 30, 35, 40 years old, who may be looking for a change of career, that could be significant.
Sure.
This program is a game changer.
Yes, sir.
Right? And I think, you know, a lot of things that we do is really trying to meet our demands in Columbus County for the workforce.
Building up our community.
This is it. Well, I want to move to a different area, another sector. We looked at the mechanical training, which is very important to a industrial systems technology program. Yes, understand the mechanics behind it and how to maintain a belt, right? Yes, sir. I want to move to a different platform. Let's talk a little bit about the automation and electronics side, just so a student or somebody potentially looking at this field understands a little bit more about what we can offer. Yes, sir. So we're going to take a minute and we're going to move to another area and continue our conversation. So now we're at this MPS automated assembly line, and this basically is a scaled down version of what a student might see in an assembly plant, right?
Some sort, sir.
And so this is something that you use in class for automation. So walk us through this thing and tell us a little bit about what's going on and how would a student use this in the classroom.
So this MPS assembly line shows, like you said, a full course assembly line of a product. So if you work in a manufacturing product, more than likely you're manufacturing some sort of good for a customer. So this process actually grabs a body from this first station, transfers it down, and this is just a process through station. So it processes through here. Once it lands on this mechanism that spins, there's sensors up under each hole. So it will detect the presence or the absence of an object, and it knows to move to the next step.
And so are these things students will learn, like the absence and presence of an object? Are those components that they would see out in the assembly line in the real world?
Yes, sir. Yes, sir.
Okay.
So with automation, any sort of automation, you have to have a system that's running and then some means of communicating back so you know what step in the process you're actually in, which is where the PLCs come in.
Okay.
So once the sensors sends a signal back to the PLC knows it needs to proceed to the next step. So as you can see, we're transferring down and we're getting ready to add some components to this housing.
Because it's building a part, basically.
Yes, sir.
It's building a device, something
Something you want to sell to somebody.
somebody will sell to somebody.
Yes, sir.
Okay.
So when we get over here, our body transfers down, our FANUC robot picks them up, sets them in a stable position so we can add the next components to it.
Okay. And this FANUC robot is, again, a scaled down version of the exact same component that they're going to see out in industry.
Yes.
Right?
To depending on the manufacturer, it may be a little bit different depending on the use, but for the most part.
And they basically learn how to program this.
Yes, sir, they do.
Okay.
So then after our FANUC robot sets up our body in place, it will actually insert a shaft, the inside of the body, a spring on the shaft, and then it will put a cap on it and close the part off.
Okay.
So that's the process you're seeing this robot slowly doing now.
So it's basic. I mean, it's making a complete device as if the device is empty.
Yes, sir.
And making an actual working component, something that actually functions.
Correct.
Right. So along the way in this assembly line, if a student is in here working on this and there's a trouble area, or maybe this red puck didn't stop at this specific area, is that part of the diagnosis that a student would troubleshoot or understand?
Yes, yes it is. So my first thing, when you're dealing with sensors like these, my first indication that something's wrong is there's something wrong with the sensor.
Okay.
It didn't pick up the object, it didn't stop the object passed through, whatever it may be, more than likely it's a sensing issue.
All right. Well, why don't you come on around here to the back side and we'll let this finish building a part. But basically with this puck, when it gets one of the round tops that goes on top of it, they're separated out by the color, whether it's red or silver, and then I guess from there it would go to some type of distribution piece.
Right. So your last station here is your sorting station. Although it looks like it sorts them by color here, in the real world it'll be sorting by type of material. So it would sort it through here, then it's ready for a packaging process to be boxed up and shipped to a customer.
That's fantastic. Well, a great tool for this lab for industrial systems technology, right? Also used in other programs, the mechatronics and electrical engineering will get a taste of this, but really for us and this student, it's really about maintaining all these different devices so that this thing can completely build this puck.
That's right.
Yeah,
Yes, sir.
critical.
Yes, sir.
That's why when somebody gets out there, they're making $70,000 a year plus,
That's right. Yes, sir.
That's good. I want to thank you for being here today. My name is Chris English. We have Josh Smith with us today, and I want to thank you for being here and taking us through a walk of industrial systems technology. It's a great program. Call Southeastern Community College to get involved and find out more about this program. You can also visit us on seccnc.edu and go to programs, and you can find industrial systems technology. We're open for enrollment. We want you to be in this program, and we want you to be employed in Columbus County. Until next time, I want to say thank you and have a great day.